What do you know of the moon's mysterious eternal darkness? For many years, people have been curious about the dark side of the moon, as Earth can only view one side of this enormous space rock and cannot tell what is on the other. Our celestial companion has fascinated and perplexed us, but now, thanks to our space program, we're starting to bring to light the secrets the moon has tried so hard to keep from us. This gives us a unique look at this alien landscape. According to popular belief, the moon's dark side is the one that no one ever sees, the one that faces away from Earth, and the side that faces the cold, black expanse of space. So what could scientists have found on this side of the moon? Could it be a safe haven for extraterrestrial life? Join us as we unravel the secrets of the dark side of the moon. The moon, which is located about 250,000 miles beyond Earth's habitable atmosphere, has been a source of awe for mankind for countless millennia. Our forefathers created imaginative tales to account for the strange features on its lamp-like face, because they perceived hazy shapes that made them think of something they knew. In the East, legends about a jade rabbit were used to pound the secret of life, make remedies, or combine materials for rice cakes. In the West today, children are still lulled to sleep with stories about a man in the moon. But just 60 years ago, the Soviet Union's Luna 3 spacecraft took the first pictures of the moon's hitherto unexplored far side, thus altering our enduring bond with our nearest celestial neighbour. This other side of the moon, which is sometimes mistakenly called the dark side, a term for insanity popularised by the rock group Pink Floyd, results from its synchronous interaction with Earth. Every 27.3 days, the moon fully orbits our planet, closely matching the duration of its axial rotation. Because of this, we can only ever view half of the moon at a time. 1 lunar day equals 1 lunar year. However, that is only part of the tale. Every month, the moon experiences a north-south wobble due to its tilt in relation to the ecliptic plane of the solar system. During this period, an extra 6.5 degrees of latitude beyond the northern and southern poles becomes momentarily visible as the moon swings away from the ecliptic. Then, on October 7, 1959, Luna 3 passed over the far side that was only partially illuminated, dispelling the myth that the two hemispheres of the moon were identical. From a vantage point 40,000 miles above the moon's far side, the first legible picture revealed a solitary black mare, more like a cyclops than a man. The jubilant Soviets promptly dubbed this the Mare Moscoviense, or Scene of Moscow. The name was reluctantly adopted by the International Astronomical Union. The absence of Maria, though, was the biggest surprise. These old lava deposits cover only 2% of the far side and 31.2% of the near side. How did these two quite different lunar faces come to be? A glancing blow from an impactor the size of Mars, Theia, struck Earth some 4.5 billion years ago, according to current theories. Massive amounts of material were finally dislodged by this impact and consolidated to form the moon, in an orbit that was synchronously locked. Over millions of years, the Earth-facing near side of the moon boiled from the intense heat emitted by our young planet, causing the far side to cool, and a gradual temperature difference to form between the two halves of the moon. Although meteoroids struck both sides of the moon equally, the moon's crust grew due to the heat differences and preferential concentrations of specific elements. Luna 3 did manage to discover a few dark craters, including Mare Ingeni, or Sea of Ingenuity, and a few others. Thomson, whose rim was severely worn by ancient lava, the rough-floored O'Day, and Van der Graaf, a figure-8 crater with mysterious groove-like textures throughout its edge. Ingeni was formed 3.8 billion years ago by an impactor about the size of Jamaica, and it stands just across from Mare Imbrium. Experts believe that the event's tremendous seismic waves impacted the moon's far side, causing earthquakes, landslides, and topographic furrows. Lunar Reconnaissance Orbiter data verified that the light-coloured swirls seen by Apollo 15 astronauts along the southern rim of Ingeni were not higher or lower than the surrounding environment. Their presence likely indicates that the solar wind is unable to completely weather the surface due to residual magnetism in the crust. Charged particles from the solar wind are unable to reach the lunar surface in certain areas due to localized magnetic fields. Thus, magnetically shielded regions keep their relative brightness, while soil without protection gets darker with time. Luna 3's images showed a prominent luminous streak snaking across the terrain close to the equator. Though this proved to be premature, it was called the Soviet Mountains. Then it came to be known as Giordano Bruno. It was found by 5 monks from Canterbury on a July evening in 1178, observing the moon erupt in flames, twist like a wounded serpent, and finally become black, turning the crater into an object of historical interest. It was postulated that the monks may have seen Giordano Bruno's birth. Indeed, the crater is very young based on its dazzling rim and highly reflected rays that meander for around 180 miles. It's not that young though. Within the previous millennium, an impactor that gouged Giordano Bruno would have sent 10 million tons of debris into orbit and caused a meteor storm that lasted for a week on Earth. There is no documentation of any similar occurrence in the past. It seems more likely that the monks of Canterbury were lucky enough to witness a small impact at roughly the same spot, since they were in the right place at the right moment. More so, Luna 3 located a crater far to the south of the moon's far side, so impressive that it would subsequently be used by Apollo astronauts to help them navigate this unforgiving grey terrain. It was named for Soviet rocket pioneer Konstantin Tsiolkovsky and is more than 100 miles wide. Although it isn't the largest crater on the moon, its striking W-shaped center peak and towering terraced walls that sweep down to the dark mare floor make it readily recognizable. It's evident that Tsiolkovsky also had an impact on a large number of nearby craters. It invades the weathered Fermi, connects to Waterman through a winding valley, leaves behind secondary impacts that resemble a string of pearls in the direction of Mendeleev, and splatters the inner walls of Neumeen. Tsiolkovsky, as seen via Vorden's window from a height of 10 miles, showed Maria concentrations in the east and south and floored it with stones the size of skyscrapers. Vorden speculated that whatever it was that made Tsiolkovsky had to have slammed into the moon like a pebble in a pond, sending the distinctive central peak bouncing back from the lunar core. Apollo 16's Mattingly described it more whimsically as a marshmallow floating atop hot chocolate. It should come as no surprise that Tsiolkovsky topped experts' lists of locations to investigate, with astronaut Jack Schmitt, a geologist, strongly advocating for the landing of an Apollo crew there. But to route communications back home, as China's Zhuiqiao relay does for the Chang'e 4 probe, 2 satellites would need to be positioned 30,000 miles above the far side, as there would be no visible Earth in the sky. The only naked-eye far-side explorers to date are the 24 Apollo astronauts who circled the moon between 1968 and 1972, and instead of wasting time marveling at the far side on their first visit, they focused on entering lunar orbit securely. NASA's trajectory planners had precisely calculated when the astronauts would vanish and reappear from behind the moon, as well as the point at which they would lose and then regain radio communication. However, Apollo 8's Frank Borman was astounded by how accurate their projected figures were. A strange hush enveloped the spaceship when the crew heard Mission Control's voice cut out precisely when they were informed it would. With a half smile, Borman turned to his crew and asked them if the flight director had deliberately shut off the radio. You would assume astronauts would run for the windows upon seeing a scene they had never seen before. But the mission had to come first, because Apollo 8 could have crashed into the moon if the trajectory experts had made a mistake in their calculations. It was not the first time it had happened. The unmanned Ranger 4 probe struck the far side close to Mare Orientale's western edge in 1962 after failing. Borman wished that his men would not follow. Neither did Mission Control, who experienced excruciating radio silence for an extended period. The far side provided amazing seclusion for astronauts who were left alone in lunar orbit, as they were cut off from Earth for 48 minutes during each 2-hour journey around the moon. I am alone now, truly alone, and absolutely isolated from any known life. I am it, wrote Apollo 11's Mike Collins. If account were taken, the score would be 3 billion plus 2 over on the other side of the moon, and 1 plus God knows what on this side. Of course, the term dark side is misleading, for the moon's unseen face receives equal sunlight and shadow to the near side. But when it was truly dark, with no sunlight or earthshine, it transported Collins back to being alone on a skiff in the Pacific on a pitch-black night with only the stars and the unlit ocean for company. In January 2019, the Chang'e 4 probe from China successfully landed on the far side of the moon near the South Pole Aitken Basin, inside a crater called von Karman with a dark floor. The once hidden face of the moon holds enormous potential for the future. As a suitable underground home away from cosmic rays and the sun, a collapsed lava tube in Mare Ingeni might be an excellent choice for humanity's future visit to our nearest planetary neighbour. Large far-side craters such as Daedalus or Saha, with no electrical interference from Earth and absolutely pristine skies devoid of any atmospheric distortion, would be ideal locations for powerful telescopes. With the use of these lunar scopes, we might even be able to detect extraterrestrial signals, look for water ice, or even uncover helium-3, which could help alleviate the world's chronic reliance on fossil fuels. Our knowledge of the lunar landscape grows as we learn more about the moon's far side, which brings us one step closer to understanding the cosmos and its secrets. Let us know what you think in the comment section below. To see more videos like this, subscribe to our channel and enable notifications. See you soon.